Okay, last time we finished until voltage and current divider. Okay, we go to the voltage divider. Last time I left, there is some mistake that I need to correct today about the voltage divider. So for the voltage divider, you know that voltage for the series voltage is different, current is the same. By applying Ohm's law, you can use a conventional method and voltage divider method. I will show you both way. Last time when I left you, we have a little bit different answer for R equivalent using a voltage divider and current divider. But today I will make a correction for our last time calculation using current and voltage divider. If it's too resistant, it's okay. If it's more resistant, last time we do a little bit wrong calculation, right? For this example, V equals to I1 R1 or V1. So this one is V1. V1 equals to I, which is I over here, times R1. So voltage V1. V2 equals to I R2. I, because you are using the same I across these two resistors R1, R2. So the same I, you use the same I. V2 equals to I R2. So this one. So the total voltage for this circuit, V equals to V1 plus V2. V1, I1, R1. I1, R1. If you multiply here, here V2 is I R2. I times R2. So you take out, it just look like I R1 plus I R2. So you take out these two I going here. So it become I R1 plus R2. Okay, next. To find the voltage, for example, if you want to find the voltage across R2, which is here. So the voltage here. So how to get the voltage here according to the voltage divider? According to the voltage divider, I equals to V2 over R2. This one because you want to find the voltage across R2. Okay, remember last time V2 equals to I R2. I is equals to V2 over R2. So that's why you got V2 over R2 here. So V2 is equals to I. V2 is equals to I times R2. So I here, you can use I over here. So I here is equals to I equals to V over R1 plus R2. So V over R1 plus R2 times R2. Why times R2? Because of V2 equals to I times R2. I is equals to V over R1 plus R2. So you get V over R1 plus R2 times R2. So it's become this one. It's become V R2 over R1 plus R2. So you take out V outside. So the formula for V2 is equal to R2 over R1 plus R2. Actually, if you remember, it's okay. So this is the way I show you how to get R2 over R1 plus R2. So it's quite simple for voltage divider actually. So if you want to get V2, V2 is equals to R2 over R1 plus R2 times voltage supply over here. So if you want to get V1 is equals to R1 over R1 plus R2 times voltage supply. So actually this is all about the formula for the voltage divider. The calculation that I show you is how to get R2 over R1 plus R2 times V for the V2. Where is the formula come from? Are you clear, everyone?
Yes, madam.
Okay. So for this example, find the voltage drop across the resistor. You can use previous method or you can use voltage divider method. For previous method, this is a method that we always use to calculate voltage and current across series resistor. This one is a voltage divider. Oh. Okay. For the previous method, if you want to calculate, for example, we call it V1, V2, V3. So this one is V1, V2, V3. Okay. So V1, if you want to get V1, first of all, you need to find I. Oops, I across this loop. So in order to get I, so you must get R equivalent. 5, 15, 15 plus 7.5?
22.5.
22.5K.
22.5 kilo ohm. So for if you get the R equivalent for the conventional previous method, if you want to calculate V1, so V1 equals to I times R1. So I, how to get I? So V equals to IR. I equals to 45 divided by R equivalent is 22.5 kilo ohm. So what is the value for I?
2 milliampere.
2 milliamp.
I is 2 milliampere. Correct, eh? Okay, I is 2 milliampere times by 5 kilo ohm. So how much for V1?
10 volt.
Again?
10 volt, madam.
10 volt. Okay, so 10 volt. So if you use the voltage divider, so the voltage divider is, if you want to calculate for the V1, so you use R1 over R1 plus R2 plus R3 times by voltage. So you got R1 5 kilo ohm divide by 5 kilo ohm plus 10 kilo ohm plus 7.5 kilo ohm. So you got like this lah, times 45 volt. So you got 10 volt. So the answer here is should be the same with here, the calculation. Okay, for V2, V2 is equals to 2 milliampere, which is the same current, times by 10 kilo ohm. So the answer should be 20.
20 volt.
Everyone got 20 volt, huh? So formula here is for the V2, so R2 over R1 plus R2 plus R3 times V. So R2 is 10 kilo ohm. 10 kilo ohm divided by R1 plus R2 plus R3, you got 22.5 kilo ohm times 45. So here you got 20 volt. So it's the same here and here. So about V3 is equals to 2 milliampere times 7.5 kilo ohm. So how much you get here?
15.
15. Okay, 15 volt. So over here is R3, because here R3 over R1 plus R2 plus R3 times V is equals to 7.5 divided by 22.5 kilo ohm times 45 volt equals to 15 volt. So 10 plus 20 plus 15, it will be the same with the 45 volt. Okay, so that's for voltage divider. And now we go for current divider. So for current divider, for the previous conventional method, we use 1 over R1, which is 1 over plus 1 over R2. Here, we use R1, R2 over R1 plus R2. For the I1, so you will use a resistance R2. I1 is equals to R2 over R1 plus R2 times I over here. So for I2 we use supply here, resistance R1, R2. So either this one this one you have voltage over here. So for the current I1, so using R2 over R1 plus R2 times I. For I2, which is I2 is equal to R1 over R1 plus I2 I. Okay, last time when we do calculation, we have a little bit different with the conventional method and voltage divider. This is because we have 3 resistance connected in parallel. Okay, for the conventional method, we do for R equivalent is equals to 1 over 1 kilo ohm, 1 over 3 kilo ohm, 1 over 2 kilo ohm, and then 1 over all. So you got 545.45 ohm. Can you do verification? Is it correct?
Correct.
Correct. Okay. So I total, which is OI, I total is I over here. I total is equals to voltage over voltage supply over R equivalent. So voltage supply is 6 volt. So you got 6 over 545.45 ohm. So you got 0.011 ampere for the current I over here. 0.011 ampere. So if you want to get I1 over here, so by using conventional method, you know that the voltage here and here and here is the same because they are connected in series. So you can use the same voltage, different calculation for the current by its own resistance for R1, R2 and R3. I1 is equals to 6 volt divided by 1 kilo ohm. So you got 6 milliampere. I2 over here, 6 divided by 3 kilo ohm. So you got 6 volt divided by 3 kilo ohm, 2 milliampere. For the I3 is over here, is equals to 6 over 2 kilo ohm equals to 3 milliampere. So you got 6 to 3 milliampere for the answer for the I1, I2 and I3 using conventional method. Okay, now we go for using current divider rules. To calculate the R equivalent, you need to get this one, these two, for example, this, you need to make them to R1 and R2 because the rule is you have to have R1 and R2. So I try to verify this one because last time we do realize that it's different when I give you the formula. But actually you have to combine them. if you want to get R equivalent total, this one, so R equivalent total, you need to get REQ1, which is R2 and R3. You have to combine them first, these two, by using R2, R3 over R2 plus R3. So R2, R3 is 2K times 3K divided by 2K plus 3K. You got 1200 ohm. So when you got 1200 ohm, this one is, we call R equivalent 1. So you have another over here. So do R equivalent 1 in parallel with R1. So you get R equivalent total. R equivalent total is equals to R equivalent 1 times R1 over R equivalent 1 plus R1. So R equivalent 1, you already calculate, you combine R2 and R3. So you got 1200, which is 1.2K times 1K for R1 divided by R equivalent plus R1. So you got 545.45 ohm. So you get the same with the one that we calculate using a conventional method. So last time when we do this, we cannot get 545. We got something else. Remember that in our class last time? It's in your class. Okay. So I total, to get I total is equal to V over R equivalent total. So you got 6 over 6 volt divided by 545.45 ohm, 0.011 ampere. So you got the same with the conventional method that we calculate before. Okay, how to get I1? This I1 here. This one is I total equals to 0.011 ampere. So you got I1, I2, I3. So for I1, to get I1, so I1 is here. So this R equivalent total, you use R equivalent total. So in order to get I1, so you use R equivalent total over R equivalent total plus 1 kilo ohm, which is R1, times by 0.011 ampere, which is I total. R over R equivalent over R equivalent plus R1 times by I. So it's equals to 6 milliampere.
Stabler, madam.
Stabler. Formula dia apa? Formula for current divider. Formula for current divider, if you want to get I1, so I1 here, so you use R2 over R1 plus R2 times I. Are you clear until here?
Yes, madam.
Okay, for the question, from that question, you have I total over there, okay, 1 kilo ohm. And then you already simplify for R2 and R3, you got here 1.2 kilo ohm, 1,200. So this is I1, this is I2. Okay. So this one is already become R equivalent 1. So it's the same with this formula. To get I1 is equals to R2 over R1 plus R2. Okay, use this formula, I1 times I. So in this case, I1 is equals to R2 is 1.2 kilo ohm divided by 1.2 kilo ohm plus 1 kilo ohm times 0.011 ampere. Okay, you got 6 milliampere. Are you clear? If I show you here,
Yes, madam.
Our previous circuit, it just look like this, right? So this one is R1, this one is R2. This one is R3. Okay, so we combine R2 and R3, it's become R equivalent 1. So when we simplify R2 and R3, you got 1.2 kilo ohm. So that's one. We finish until I1. We cannot calculate I2 yet because I2 is R equivalent. Then we can do calculation on I3 first. I3, you need to make R equivalent between R1 and R2. So to get R3, this one is R3. So this R1 and R2, you have to make them R equivalent 2. Then you have a voltage supply over here, 6 volt. So in order to get R equivalent 2 is R1 and R2. So R equivalent 2, you get R1 times R2 over R1 plus R2. R1 is 1 kilo ohm times 3 kilo ohms R2 divided by 1 kilo ohm plus 3 kilo ohms. R2 equals to 750 ohm. So here is 750 ohm. This one is R3 is 2 kilo ohm. Okay, in order to get I3, what is formula for I3? I3 is equals to R equivalent 2 over R3 plus R equivalent 2 times by I. So R equivalent 2 is 270 ohm divided by R3 is 3 kilovolt plus 750 ohm times by 0.01 ampere. So you got 3 milliampere. So here you got 3 milliampere. This one you got 6 milliampere. Then you use current in is equals to the total current out. I totals is equals to I I1 plus I2 plus I3. If you want to get I2 is equals to I total minus I1 minus I3. So you got I total minus I1 minus I3 equals to I2. So 0.01 is I total minus I1 minus I3 equals to I2. So you got 2 milliampere for I2. Anyone? You want to ask any question? Okay. So it's the same with the previous one. So the answer should be the same lah. I1 is 6 milliampere. I2 is 2 milliampere. I3 is 3 milliampere. So by using both method, either conventional method or current or voltage divider method, so you can have the same answer. Okay, this is just a refreshment back about the voltage. So this one is negative V1 plus minus plus. So you got negative V1 plus V2 plus V3 minus V4 plus V5 equals to 0. V2 plus V3 plus V5 equals to V1 plus Vc. This is just a refreshment to you. Then we back to the voltage and current divider. So how about if you have voltage divider for the resistance, there is a lot of resistance connected in series. So for the R total, you got R1 plus R2 plus R3 plus Rn plus how many R until infinity. So I total is equals to voltage total, which is voltage supply over here, equals over R total So R total is, if you have many R connected in series, so you just need to put them all over here. So VT over R total. So I total, which is I total over here, I total is equals to IN. Current is the same in series. Until infinite, the current is still the same. So VT over RT for the IT, I total is equals to voltage total over R total. IN is equals to voltage across Rn over Rn. If you want to find Vn over here, so In is equals to Vn over Rn. Okay. So R total is equal to R1 plus R2 plus R. How many R you have? Vn over Rn. So this is the Vn. If you want to calculate the voltage across resistance Rn, Vn equals to Rn over R equivalent total times voltage total. So this is example. If you look at this example, this is the one that come out in last year final exam. If you look at final exam question, I already upload in e-learning. You can see one of the question is about this. Okay, voltage divider, find the V2 across R2. For example, how to get the V2 value. So we already do a calculation before using a previous and conventional method. But some of the question they ask you to design a voltage divider that can give you the output V2 equals to blah 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 value, and then you have to do design. Voltage divider usually you will have 2 or 3 resistance. It's up to you to design it. But the most easiest one is to have R1 and R2 only. Okay, in this case, for example, they don't give you V1 and V2. They give you resistance. So V equals to IR. V is 12 volt. I is I total times 30 ohms. So you got the current is 0.4 ampere. So if you want to calculate the voltage across V2 over here, so it's equals to I times R2, 0.4 ampere times 20 ohms over here. So you got 8 ohm. So if you want to get V1, so I 0.4 times R1, so you got 4 over here. So 8 volt plus 4 volt, you get 12 volt. So if you use a voltage divider, so V2 is equals to R2 over R1 plus R2 times Vs. So V2 is 20 divided by 10 plus 20 ohms. So you got 8 volt. So if you want to get V1 is equals to Vs times R1 over R1 plus R2 equals to 12. R1 is 10 divided by 30. Okay, so you got here 4 volt. Okay, so V1 is 4 volt, V2 is 8 volt. Okay, this is example. In the teaching, the question also come out in the final exam. Design a voltage divider circuit with an output of 12 volt and a current of 50 milliampere using 20 volt battery. Actually, the circuit is not given to you. It's only statement until here. So you only have this statement. So you have to come up with the circuit drawing and this all calculation. So imagine that you have only a word design a voltage divider. You know a voltage divider, you know that there is a voltage will be divided by 2. So you have to do like this. You have output 20 volt, okay, draw 20 volt and the current of 50 milliampere. Okay, draw a current 50 milliampere using a 24 battery. Okay, you don't know the R1 and R2. It's not given to you. But it says that it will have output 12 volt. So you can have either here output 12 volt or you can choose here output 12 volt. It's up to you. In this case, I choose 12 volt over here for R2. So what did you do is V equals to IR again. So you want to calculate the R total because you don't know R1 and R2. You only have one information here, two information here, information here, 3. Okay. So V equals to IR, V is 12 volt, I is 50 milliampere, resistance, you don't know resistance, so the resistance total for this R1 plus R2. So R total is equals to 400 ohms. So this one is R1 plus R2 is already 400 ohm. But what is R1? What is R2? How do you know? Okay, you know that R1 plus R2 is 400 ohms. You know that V out over here, V out, which is we call as V out or V whatever. So we know that V, if you want to calculate at V, or we call it V at R2, is equal to V in, or sometimes we call it as a voltage supply in my lecture. Okay, voltage at R2 is equal to voltage supply 20 volt times, because you want to calculate at this area, so R2 over R1 plus R2, R2 over R1 plus R2 times Vs. So here you got R2 is equals to 2 times 1, 2 times 20, 20 times 12, you got 240 ohm. So you know that R1 plus R2 is equals to 400. R2, you know that is 240. So you can know R1. R1 is 400 minus 240. Okay. R1 is 160 ohm. So if you want to calculate the V1, which is over here, so you already know, you design this one is 12 volt. So V1 is equals to I1 R1. So I1 is 50 milliampere times R2 is 160 ohm. So you got 6 milliampere. So 6 milliampere plus 12 milliampere over here. 6 plus 2 is 20 volt. So means that your design is correct. But some of the students, they don't know how to design the voltage divider. So sometimes in the question, maybe they ask you to design a voltage divider or current divider. But last year, the question come out like design a voltage divider. So the question is like this lah, but the value is different. Are you clear until here, everyone?
Yes, madam.
Yes, yes, madam.
Okay. You can try to calculate this. Calculate the voltage across R1, R2, and R3. So R1, voltage across R1 is R1 over R1 plus R2 plus R3 times voltage total. So R1 is 2 ohm divided by 2 plus 4 plus 6. So you got 12 ohm. So 2 divided by 12 times by voltage supply 12. So you got 2 volt over here. 2 volt. For voltage across V2. So V2, V1, V3. So V2 is equal to R2. So use 4 ohm divided by total resistance is 12 ohm times 12 volt. 12 ohms. So you got 4 volt. V3 is equals to R3. R3 is 6 volt, 6 ohm, sorry. Divided by R total is equals to 12 ohm times 12 volt. So you got 6 volt. 6 plus 4 plus 2 is 12. Is it okay until here? This is just a refreshment only, the easiest one. Okay, can you give me the value for the voltage drop across V8 ohm?
For
For
for forward.
what? For what?
Yeah.
Let's
For
check. Okay, R equivalent total is equal to 30, right? Is it correct? 30? 12 plus 6 plus 8 plus 4. So you got 30 ohm R equivalent total. I total is equals to 15 over V equals to IR, V over 30. So 15 divided by 30, you got 0.5 ampere. So I 0.5 ampere times 8 ohm times 8. So you got 4 volt. Very good. Thank you. Okay, next. Determine the voltage across 15 ohm resistor. So they want you to calculate voltage over here by using a voltage divider rule. So you can use R equivalent. R equivalent, you can use any method. R equivalent for 3 and 15 ohm. So you got 2.5 ohm. So you got 2.5 ohm like this. And then you calculate the voltage at here. Voltage at here. So V equals to IR. V equals to IR. I across here should be the same because they are all connected in series. So R, what is the current over here? So if you use a voltage divider rule to calculate the voltage across 2.5 is 2.5 divided by 5 plus 2.5 plus 25 times 30 volt. So this formula is R equivalent over R equivalent 1. So R equivalent 1 is in between R3 in parallel with R4. So this one is R equivalent 1. So R3 in parallel with R4, you call it as R equivalent 1. So this one is R equivalent 1. So to get a voltage at R equivalent 1, R equivalent 1 over R1 plus R equivalent 1 plus R2, which is this one is R2. R2, okay. So you got R equivalent is 2.5 ohm divided by 5 plus 2.5 plus 25. Then you have to times by voltage supply, which is 13 volt. So over here, you get, how much you get over here? What is the voltage across V R equivalent 1? Can you calculate? How many volt?
1 madam.
Okay,
1 volt.
1 volt. Okay, 1 volt. So you got 1 volt, and then this one actually R equivalent. R equivalent 1 is equals to 1 volt. This one is R1, this one is R2. Okay, so R equivalent 1, this one is 2.5 ohm, so you got 1 volt. So where even though this one is R equivalent, if you expand them back to the original circuit, so this is in parallel. So this one 1 volt, this one also 1 volt. So the answer is the voltage across resistance 15 ohm is 1 volt. Okay, are you clear until here?
Yes, madam.
Okay, so I think we finish only until here, and then next week I will continue with the more example for the current divider.